For problems 21 through 23, we're just being asked to solve. And you know that a solution to a quadratic is going to be its x-intercepts. And its x-intercepts can only be found if I have a quadratic in factored form and equal to 0. All of these problems are equal to 0, but none of them are factored. So let's just go ahead and factor the first one. Let's just factor all of them, really. So first thing I look for in factoring is a greatest common monomial. Do I have a common monomial? Yes, x. X squared divided by x is x. 1.5x divided by x is 1.5. So I will break it apart, set each side equal to 0. So I get x is equal to 0 right here. And minus 1.5 minus 1.5, get x is equal to negative 1.5. For number 22, look for a greatest common monomial. There isn't one. So I know it's not a difference of squares or a square binomial because 8 is not a perfect square. It's a cube, but not a square. So then, let's factor it. What two numbers multiply together equal 8, but add together to get 6? And that would obviously be 2 and 4. So then, set both equal to 0. Break it into its little two linear parts. So I get x is equal to negative 2, and over here, x is equal to negative 4. For number 23, we have 8x minus x squared is equal to 0. Same deal. Greatest common monomial is x. But I'm going to factor out a negative x just because it makes life a little bit easier because we really want that squared term to be positive. So I get negative x times x minus 8. I divided both of these terms by negative x. That gets to be positive x. This quotient is negative 8. Set both equal to 0. So again, x is going to be equal to 0 over here. And here, x is going to be equal to positive 8. So those are your, oops, those go together. Those are your answers for those three problems.